Hello everyone, welcome to part 7 of the video lecture on registers. So we were seeing what are all different types of registers and all which can store data as well as shift data. So accordingly the serial in serial out register, serial in parallel out register, parallel in serial out register, and parallel in parallel out also. So those four category we discussed so far. Now let's see some further variations like parallel access shift register. This is something I already told you. This access, the word access typically means both read access or write access, right? Something is there, some memory element is there, we have to read the data from the memory as well as we have to write information into the memory. So depends on what you want, right? So in general I can call it as an access operation. So whether you are reading the data or writing the data, so we should be able to do both read and write in parallel. Okay, so that is the general notion of parallel access. And also there is a word like shift. So read and write should happen in a parallel fashion and also should be able to shift the data. So typically we have something called parallel in parallel out register. Hope you remember in some previous video I discussed this, where we are reading the data and we are writing the data. I mean both read and write, and I mean how the registers are being flip-flops are being filled with the data and how data is taking out from the register, right? So both are happening parallelly, but there is no option of shifting the data. Now parallel access, that is what we called as PIPO register, is nothing but the parallel access register, which can parallelly input data and it can parallelly output data, right? That is just a parallel access register, but now it is parallel access shift register. As we are discussing shift register, we can think of this variation also, right? So this is something that can do that parallel in and parallel out with the shifting in addition, right? So this is something, just watch the previous video, you will understand the idea very easily, because there I introduced the how this multiplexer can be introduced into it for load or shift, like that. Whenever we have sometimes whether to shift the data, because now we have the same confusion that we seen in the last video, like parallelly sometimes we want to write the data parallelly, right? Sometimes we want to read the data parallelly, sometimes we want to shift the data. So the shifting the data and writing data parallelly, that may get conflicted, right? So that time, so whether you want to shift the data or write the data, that is being decided by the controller input, that is this one, shift bar load. Okay, this we already seen, you can use it in this way, or shift bar load bar, I mean shift or load bar. So anyway, so here by default what does it mean? So this is our control input, right? So this is our control input, so that will control the operation, right? And if this is equal to 0, that means shift operation, and this is equal to 1 means load operation, right? So that is the meaning of this particular thing. Okay. So that is meaning of the whole thing. Yeah. Now what about it? This looks messy. Okay, you got the idea, right? So this is our control input. Now what else? So how to so that will act as this shift bar or load will act as the control input for the multiplexer, I mean the select input of the multiplexer. So you know by default multiplexer, whenever the select input is 0, that corresponds shift operation, it will select the input is 0, that serial input will be selected, right? So that shift operation, you know, the what is the serial input you want to give to the first D flip flop. For the second one onwards, it is output of the previous one, so like this, right? And for the third one onwards, like this. So this is a shifting operation. For making that shifting operation happen, the output of the previous flip-flop should be connected as input to the next one. So then only you can shift the data over this line that is shown, right? And for this we are making the select line. So whenever the select line is having a value 0, so that it will do like this, right? So on background 0, we want to implement the shift operation. Clear? Now let's see. what will happen when the control input is say 1? 1 means I want to load the data. Load what kind of data? The external input, right? So the external input, that is parallel input, is fed like this. So these are all the parallel input, say the least significant bit or MSB, how you are interpreting the data. So the say MSB bit and the LSB bit, like that. Okay, the input. So when it should happen, whenever this control input is having a value 1, that means the select line is having a value 1. So the input 1 will be selected. That is nothing but the external input that is fed to the all the flip flops simultaneously. Okay, so that about this. So that will nicely controlled by this control input line. So that about it. Now it is clear, right? So if you are giving a value of 0, it will work like it will do that shifting operation for you. Whenever you are giving a value of 1, that loading will happen and also all these outputs are connected. From the circuit we have a connection from all the flip-flops towards as the output. At any point if you want, you can take all the 4 bits as the output also. So everything is possible. Parallel write as well as parallel read. This outputting operation is reading, right, and the inputting operation is write, and shift operation also. Everything is possible now. And here it can again it's shifting from left to right only, but next we will see something which can shift in both directions. So that is a slightly different variation of it. Okay, so far by default shift means shifting towards right. Yeah, that about it. And what I explained is illustrated here. Like whenever I am giving that control input to be 0, the first input will be selected, and that's or the output of the previous flip flop will be connected as input to the next one, so that shifting operation will happen. Similarly, whenever this control line is having a value 1, the external input is fed into the circuit. You can clearly see this by this. So this kind of a bridging will happen. Multiplexer is basically a bridge circuit, right? One of the input will be bridged to the output. So now you are getting many applications of multiplexer. So see, when I discussed that multiplexer, I explained a few. Now you can see where it is actually applied. So this is how, see, registers also now we are seeing it like how it is to be implemented, and see usage we will see later. Okay, so like that everything you are studying, like these are all very fundamental circuits that are being used in our system. Register, and it's important anyway in computer organization subject also you will explore this register concept, memory hierarchy, everything in detail, and that time you should link with what you learned already. And this is how your teacher is telling about a register, you should be able to visualize this. See, this is how the register is there, then it is very easy for you to understand the concept. So that is why always build the concept in a systematic way, right? It's don't study in a exam point of view, just understand the concept. So that is the right way. Anyways, yeah, that about it. Okay, thanks for watching. So let it be a small video. So you hope you got an idea about what is this parallel access shift register. Before register is nothing but parallel access register which can parallelly input data and output data, but here we can do that shifting also. So that is why it's come under the category of shift registers. Thanks for watching.